everyone, and welcome back to Aussie's Young Learning Emporium. In today's video, we're going to be looking at a rather peculiar question to start with. What is the area of this figure right over here? Now, some details that have been given to us is that the distance between adjacent dots is 1 centimeter. So this means that if we draw out this triangle a bit more nicely, real quick, then we know that this is 2, this is 2, and this is 2, because we've got 2 dots, right? So when we calculate it, 1 centimeter plus 1 centimeter, we're going to get 2 centimeter on all of the sides. So that's what we're going to do. We're going to construct this triangle like so, and this is going to be the triangle we're going to be calculating the area of. Now most people would see this, oh well, this is a equilateral triangle, right? So that means when I draw my median or my perpendicular bisector, we get a 90-degree angle over here. And now we can use the Pythagorean theorem, which is a square plus b square is equal to c square. So let's go ahead and apply that like so. So I'll just draw my right triangle, and we know that this is going to split this side. So we know that this is going to split this side in half. So this is half and half of 2. So that means that our base is going to be 1. And obviously this side is the full length. We know what this is. So this is a 2. And this, let's name it x. So this means that x squared plus 1 square is equal to 2 square, which is x squared plus 1 is equal to 4, which is x squared is equal to 3. When we send the 1 on that side, it becomes a -1, right? So that's why it is a 3 on our left side. Sorry, on the right side. So now that means that our x is equal to root 3. Now what we can go ahead and do is to apply the area of triangle formula, right? So that means that the area is equal to half times base times height. So since we know that our height which was our x, is equal to root 3, and we know that our base, which is basically over here, this is our base, and we know that this was 2. So we're just going to use that knowledge to say that our base is 2. Then that means that our area is equal to half times 2 times root 3. So we can cancel out the 2's, and we'll get that the area is equal to root 3 centimeters square. We need our units in there. However, it works all good for this particular triangle. But what if I told you there was a way to calculate the area without using the Pythagorean theorem? In fact, let's forget that this ever formed a right angle over here. How would we do that? This is where I introduce to you all the grand formula called Heron's formula. Please excuse me if I said the name wrong, but this formula is amazing. It's amazing, yes. It works for any triangle, any type of triangle. And here's basically the formula. Let's write it out in black. So he says that the area of the triangle is equal to under root s minus a, s minus b, and s minus c. Now, first glance, you might look at this and say, hey, there are 3 brackets. Triangles are made up of 3 sides. Could these have something to do with the sides of the triangle? Maybe. You're quite close if you did get that. So let's start by looking at S first, though. So what S really is the semi-perimeter. Perimeter of the triangle. Now we know that perimeter is, if we've got a triangle like this, we've got 1, 1, 1. So perimeter is basically the length around the shape. So it's going to be 1 plus 1 plus 1, which is equal to 3. Now, what can semi mean? You may start to think of semicircles, right? What are semicircles? They are half of a circle. So that might mean that semi-perimeter is actually half the perimeter. Does that kind of make sense? Since we know that there's a semicircle, let's think of semi-perimeter as half the perimeter. Okay? So now that we know what semi-perimeter is, let's go ahead and find out what A, B, and C are. Now, as I said before, some of you may have gotten notice that there are 3 sides, A, B, C. Something has to do with A, B, C. And you're absolutely right if you thought that. Because one side is A, one side is B, and one side is C. So what this really means is we have our under root, S semi-perimeter, bracket. So there's a multiplication sign over here if you didn't know. That's all good if you didn't know. Now you learn and now you know it. Times S, which is semi-perimeter, minus one side, times, in brackets again, S minus B, another side. So these are all sides, by the way. And times S minus C, which is another side. So now that we've got the understanding of the formula down, let's put it to use. So I'll just clear up some space really quickly. And let's use this formula. Let's use this formula to calculate the area of the triangle we're dealing with. So I'm going to go ahead and draw out our triangle right here. There's our triangle. We've got 2, 2, and 2. Now, let's find the semi-perimeter first. Right? Now, we know all of the sides are 2, so all we have to do is to multiply 2 by 3, to get the perimeter. But to make it the semi-perimeter, we have to divide it by 2. That is equal to 6 by 2, which is equal to 3. Looks like we've got a 3 in our equation. That's great. Let's keep going. So now the area is gonna be under root 3, which is our S, times. We've got 3 again, because that's a semi-perimeter. As I said, there's S minus A, so we've got our S down. Now our A. So we know that A, B, C are the sides of triangle, right? So now we can just go ahead and I'll just make a little keynote with A is equal to 2, B is equal to 2, C is equal to 2, and S, as we calculated previously, is equal to 3. So now we can go ahead and plug in our values. So 3 minus A, so 2, times 3 minus B, which is 2, times 3, which is S, minus C, which is 2, and that's all. So now this is all equal to 3. Now, 3 minus 2, what is that? That's just 1, isn't it? That's just 1, which means this is 1, and which means this is 1 as well. So when we multiply all these ones, we get 1. So it's just 3 times 1. And what is that? root 3. And that is the area of our shape. That is the area. And look, if you don't trust me, let's match it with our previous answer, which is also root 3. Sorry, I forgot the the unit. But look at that. It's the same answer. And you know what? This formula is going to work for any triangle, as I said. Any weird looking triangle it's going to work for. Doesn't have to be equilateral, doesn't have to be right, doesn't have to be right, it doesn't have to be equilateral, doesn't have to be isosceles. It does not have to be any of these. It can just be a random weird ass looking triangle, and this formula will work. So I really hope it all made sense to you. I hope you learned something new and that you understand Heron's formula. I hope that you can use this in your maths class or whenever you're going for a competition. This is going to be really, really useful. So I hope it all made sense. Thank you so much for watching, guys. Have a great day. Bye!